Intrusion detection systems monitor the network for unusual or suspicious activity. The system is constantly vigilant for an attack signature. Database compromise has affected over 2.5 billion, as we see in this infographic. We can take a look and see data records compromised in 2017. We take a look a little farther down and you can see the number of breach incidents by type, by source, and down below by industry. You see it's a level playing field. Anyone can be affected. Therefore, any evidence of data exfiltration or compromise is carefully monitored. Intrusion detection systems also are tuned to recognize virus, worms, Trojans, and bot activity. Intrusion detection systems also monitor for web attacks, such as SQL injection attacks, cross-site scripting, and denial of service attacks. The Cisco Intrusion Detection System sensors can use 4 types of signature triggers: pattern-based detection, anomaly-based detection, policy-based detection, and honeypot-based detection. Another triggering method is by using protocol decodes, which breaks down a packet into the header field values and then searches for specific patterns that might flag an intrusion. Much like the way Wireshark decodes the protocols, this method allows for a more granular inspection of traffic and can reduce the number of false positives. I'm in Wireshark and I have this packet capture. Now we're going to take a look at a signature. I'll first go to Statistics and then Conversations, and then we'll go to the tab UDP. Now when we take a look at this, you can see the port values, and I can search on those. And what I'm looking for is something that's sticking out here right there, port 666. Now what we'll do is right-click, and I'll say Apply as a filter, and then I'll close this. Now, right down below here, you see the source port 666, and Wireshark has associated that with Doom. But let's take a look. I did a search on port 666. As you can see, there are a number of bad things that could possibly be associated with port 666. Therefore, you do not want that on your network. Now that's an example of using decodes. At this point, when it notices port 666, the system will alert the administrator and block the stream. So intrusion detection sensors use different types of signature triggers, such as pattern-based, anomaly-based, and policy-based detection, as well as using protocol decodes. Cisco Intrusion Detection System security appliances primarily use signature-based technology to monitor and compare traffic as it passes through the device to detect patterns in network traffic. A signature-based intrusion detection system must contain a current database of known attack signatures that is tuned to detect intrusions and malicious activity. A signature is either atomic or composite. An atomic signature is a single packet, activity, or event. A composite signature is also called a stateful signature because it's a sequence of events involving multiple packets dispersed across multiple hosts during a period. Because it is stateful inspection, the device must keep a state table. A signature engine has a parser and an inspector. The parser reads the text-based descriptions for all signatures. The inspector looks for malicious activity in the network traffic stream. There are several signature engines or categories that each has its own set of signatures that monitor for an allowable range or values. The service engines inspect common application layer services, such as HTTP, MySQL, NTP, or DNS. String engines enable the intrusion detection system to search the traffic streams for regular expression strings that might be associated with malware. Flood engines monitor for flood activity. Atomic engines create simple single-packet signatures, and sweep engines monitor for reconnaissance activity. Flood engines monitor for any host or network sending multiple packets to a single host or network, such as in a denial-of-service attack. You can easily set and modify the various parameters. Here's just a sampling. For example, you can modify protocol, the type of traffic to inspect, the rate, the threshold per second, or ICMP type, which would give us the value for the header type. Atomic engines are designed so the network administrator can create a simple single packet signature. A packet traveling across the network with a matching signature will trigger an alarm. Cisco uses several atomic signature micro engines. The atomic IP examines the headers and payloads of TCP, IP, UDP, and ICMP. Atomic IP Advanced includes advanced IP options, such as an IP version 6 packet with a fragment option header. There's also Atomic IP version 6, which are defined signatures related to IP version 6 malformed packets. Fixed TCP, UDP, and ICMP examines the fixed, or what we call immutable, portions of TCP, UDP, and ICMP headers. These are the portions that do not change. An atomic ARP examines ARP packets for ARP spoofing attacks. Within each atomic engine, the network administrator can customize the parameters. For example, with a TCP signature micro engine, you can configure specific parameters for the atomic.tcp, including direction, to TCP service or from TCP service, or which TCP flags to monitor. Sweep engines monitor for the various signatures related to sweeps and scans. Now, scanning techniques can vary, but there are some common scans. Each will have a different objective. A common scan is a ping sweep. This will send a series of packets out to identify live hosts on the network. It waits for one to respond, and then it knows which hosts are alive. A port scan identifies TCP and UDP ports on a live system looking for services that will respond. Intrusion detection systems use a signature database with several signature engines or categories that each has its own signature micro engines that monitor for an allowable range or value. In a signature-based intrusion detection system, sweep engines monitor for the various signatures related to sweeps and scans. Scanning techniques can vary. In this demo, we'll take a look at a TCP scan and see the signature as if we were right in the intrusion detection system watching the traffic as it travels across the network. I'm at this web page here at Cisco Security, which talks about threat information and more specifically, intrusion prevention system signatures. Here we see TCP SYN host sweep. It talks a little bit about the ID, when it was released, and then down below a description. This signature fires when a series of TCP SYN packets have been sent from one single host to a number of different hosts. This could be, for example, an attempt to map the network. This is indicative that a reconnaissance sweep of your network may be in progress, and it says this may be the prelude to a more serious attack. Let's take a look. I'm in Wireshark so we can see the pattern or signature of a TCP scan. I'll first apply a filter. Now what this filter did was show me only the TCP traffic with only the SYN flag set. Now this was done in a laboratory setting, so you'll see only two IP addresses, .101 and .103. To clean this up a little more, let's take off the coloring rules. And then I'll uncheck name resolution so we only see the ports. So as you can see, Wireshark does a resolution as to what service it thinks that port is associated with. I'll go into Edit, Preferences, and then Name Resolution, and then I'll uncheck Resolve Transport Names. All right, we're almost there. Let me do one more thing to make it super clear to you. I'll right-click on Destination Port, and I'll say Apply as a column. And I'll scroll down. Now you can see, as if you were the inspector in the intrusion detection system, this is evidence of a TCP scan. It's going through all the ports in an attempt to get one of the services to respond. Now in some cases, scanning network hosts is done because of a vulnerability assessment exercise or even a penetration test. But scanning and sweeping is also done by hackers during reconnaissance prior to an attack. In general, unless you have initiated the scan, you should not allow active scanning or sweeping on your network. Intrusion detection systems detect malicious activity by using either atomic or single packet patterns or composite or multi-packet signature patterns. Once a specific signature is found, the device will send an atomic alert. I'm at this website, Kaspersky Cyber Threat Real-Time Map, where we can see there is a constant barrage of attacks. We'll take a look around on this website, and I'll scroll down. It will show most infected today and some historical statistics worldwide. Here we can see top local infections in the last week and some of the variants. To stop incoming malicious traffic, the network must first be able to identify it. There is a main disadvantage in pattern-based detection in that it cannot detect unknown attacks. While malware signatures are critical in monitoring the system, the one threat that will pose a significant risk to your organization is a zero-day attack. A zero-day attack exploits unknown software vulnerabilities. Here we see in this graphic a timeline. First, the vulnerability is found in the wild. Now, there are people that specifically look for these vulnerabilities and try to exploit them. At some point, the vendor becomes aware and works on mitigating this vulnerability by creating a patch. Then at some point, the vendor will release a patch, and then the public will be made aware. However, you can see down below that until you apply the patch, your system is vulnerable. Anomaly or profile-based detection can monitor virus and malware-like behavior. It can detect new and previously unpublished attacks. This detection method requires careful initial configuration and has the following modes. We have the learning mode. During this initial setup phase, the system builds a normal profile by monitoring network or host activity for at least 24 hours. After the system learns the normal behavior, the signature triggers if activity occurs beyond a specified threshold. Now, this is important. The network must be free of attacks while establishing normal activity, or it will become part of the normal activity. During detect mode, we have anomaly detection, which is monitoring for anomalies, but it's also recording gradual changes and builds a profile of normal system activity over time. In inactive mode, this is where we turn off anomaly detection. Now, although it sounds like a better way to go, this type of intrusion detection system can be difficult to manage. It most of the time will throw many false positives, which can happen during valid user traffic. The network administrator must tune the system to adjust optimal detection thresholds. In addition, when there is any new addition to the network, the system must build a new baseline. Anomaly or profile-based detection can monitor virus and malware-like behavior and detect new and previously unpublished attacks, such as a zero-day attack. In addition to using signatures to identify threats, Cisco intrusion detection systems can benefit from reputation-based intrusion detection using Cisco's security intelligence operations. In the real world, we make our selections based on the reputation of the company or product. The collective nature of event correlation is very powerful, as it provides information to the intrusion detection systems about certain IP addresses that may have a reputation associated with malicious or risky websites. The Threat Operations Center is constantly vigilant and gathers and analyzes data on malicious activity using automated along with human interaction methods. The gathered data populates the Cisco sensor-based database. Participants contribute to the database but also benefit from the collective wisdom and information. The first step is to agree to participate. Then on the local area network, participating intrusion prevention sensors gather data and then send suspect traffic to the global correlation servers. If there is an identified event, the intrusion detection system will send information that includes signature ID, attacker's IP address and port, victim IP address and port, TCP option string, reputation rating and score, and data from the sensor health metrics. The reputation servers update the database and then share the results with other contributing networks. The Cisco sensor-based database changes often. It's best practice to set the sensor to periodically download global correlation updates from the global correlation servers. Reputation-based intrusion detection using Cisco Security's intelligence operations is a powerful feature that helps prevent threats from malware and zero-day attacks by sharing a collective knowledge. With policy-based detection, the administrator defines suspicious behavior and can create a customized policy to monitor for that activity. Policy-based intrusion detection is like pattern-based detection, but instead of trying to define a specific pattern, policy-based signatures can be used to analyze a specific type of packet. For example, having data in the flow label in an IP version 6 header. How this can be used, we can use this example. The network administrator can set up a honeypot and gather evidence of an attacker trying to exploit a vulnerability that would be indicative of a possible zero-day attack. The administrator then can create a customized intrusion rule. An intrusion rule is a set of criteria listing details and conditions the intrusion detection system must match. Much like a blueprint, the rule provides details of what to look for and what action to take once the criteria is found. A standard rule will have two sections, the header and the options. The rule header contains the action or type, the protocol, source and destination IP addresses and subnet mask, direction indicators, and source and destination ports. And the rule options section contains event messages, keywords and their parameters and arguments, patterns that a packet's payload must match to trigger the rule. If the rule is an alert rule, it generates an intrusion event. If it's a pass rule, it ignores the traffic. Here's an example of a rule header. First, we see action, which is alert. This will generate an intrusion event when triggered. For the protocol, this will monitor TCP traffic. For the source IP, this will monitor for traffic coming from an outside network. For the source port, this will test traffic coming from any port, and the operator will test external traffic destined for web servers on your network. And the destination IP address, this will monitor traffic sent to any host specified as an internal web server. And the destination port will monitor traffic delivered to an HTTP port on the internal network. Take care when writing a custom rule. You should test prior to implementation, as a poorly written rule can affect system performance. Policy-based intrusion detection analyzes a specific type of packet. The network administrator creates an intrusion rule listing details and conditions the intrusion detection system